All right, let's look at this question. Fx is continuous function, and f1 equals 2, f3 equals 4. Which of the following values necessarily exist on the domain of 1 and 3, right? So first thing first, we've got to be very clear with the continuous. Geometrically, if you see the graph of the continuous function, it will be what? There will be no holes, no jumps, okay? That's called continuous. So we use the intermediate value of theorem. First thing first, you asked me about the difference between intermediate value theorem and extreme value theorem. Let me explain to this one here. Intermediate value theorem, for example, you have a function from here is A, this is the B, right? And then because it's continuous, they have the value here, you go from here, go to here like this. So as long as X value in between here, here, the Y value will be, let me change the color here, okay? The Y value will be guaranteed in between this value. Any value of the Y function value will be occurs along the X value changing from the A to B because there is no hole here. So this is the basic explanation about the intermediate value theorem, okay? So it means as long as X changing from A to B, and then the Y value will be corresponding changing from the this we can call it as FA, and this one we call it as FB. So they can take all the value in between. That's called the intermediate theorem. Let's go back to the extreme value theorem is this. They said if you have A to B, the function domain is A to B, and the function go from here, go to here, go to here, like this, okay? Like this, right? So if you go like this, no matter what, because this function no holes, the graph no holes here. So they will have, you see, they always got a what? This is the max. And this one will be what? The minimum. Of course, the max and minimum may not necessarily be on the boundaries. Maybe, maybe not. Depends on the graph. But anyway, as long as you have A to B interval, the function there is continuous. They must have a maximum, must have the minimum. Okay, that's about the extreme value theorem. But actually, when we do this question here, they're nothing to do with the extreme value theorem. This one only for what? Intermediate value theorem. For example, like Fx is continuous. This one, right? So you see here, for example, I just graphed it here. I actually don't need graph, but I graph it here so you can visualize this one, okay? So x equals 1, this is a 1, y equals what? 2. This is a 2 here, that's this point. So this is F1, okay? And then you go, this is 2, this is 3. When you go to 3 here, this one is what? 3, 4 here, somewhere here. So no matter what route, because this point is F2 and no 3, F3 like this, huh? This point actually just what? 1 and F2, F1 like this, right? So no matter what route you're gonna go from this point to this point, no matter what, they will pass all the value in between the 4 here. This is a 4, this is a 4. And this one here is here. This value is 2, right? Because this F1 equals 2, F3 equals 4. So that means the point go through this function f, no matter what route goes, because no holes, no jumps, no breakdowns there, right? So they're gonna go everywhere, every value in between these two. This is exactly the median value theorem there. So we can see that any value in between 2 and 4 will be good for the function value. So this one equals to 2.5, okay, right? And this one is 3, also in between 2 and 4. That's good. Any number value between 2 and 4, like this one here, will be a good one. So this one also a good one. But this is only 1.5. This 0.4 somewhere here is beyond the graph of function in between function value 1 and 3. We don't know if that value will be taken by the function or not. Maybe, maybe not. We're not guaranteed, but we do guarantee these two values will be in the value of the function. Okay, so please let me know if you have any questions. Thank you. Bye bye.